Hello everyone. Today we are discussing here about Brewster's law, that is polarization by reflection, which is usually asked for 3 marks in 12th classes. We'll see this step by step and in details. Okay, so for this, let us consider the surface xy, which is the interface between the two medium, and the normal, which is the perpendicular line drawn on the surface, so which is called as M O N is the normal, and here is the source of the light. Okay, from the source of light we are getting an unpolarized light, okay, which basically hit the surface. This is the unpolarized light. So what is unpolarized light? Basically, the light will get vibrate in all possible direction and the plane. And this is the unpolarized light, which is coming from the source S. So AO is the unpolarized light, which will hit the surface at an angle IB. Okay. And as XY is the transparent medium, okay, some part of the light will be reflected here. And some part of the light will get refracted here. Okay, the refracted light will be unpolarized one. And our intention is to produce the polarized light. Okay, where we are going to make the light to vibrate in a particular direction, in a particular plane only. Okay, so this is the angle which we'll call it as a IB. And this angle is called as angle of refraction. And initially what we are going to do is, we are going to increase the angle of incidence from the smaller values. And when gradually increases the angle of incidence, at a certain angle of incidence, the reflected ray will become completely polarized. Okay? And if you furthermore increase the angle of incidence, the reflected polarized light will reduces the polarization. And meanwhile, we can see here the refracted light, which is unpolarized one. And when the reflected light is completely polarized, when it becomes completely polarized, and the angle between the reflected light and refracted light will become 90 degrees. That is the most important thing. Mathematically, we have to prove this by, okay, so then we can understand this clearly. So here, as I said, initially we have to increase the angle of incidence from the smaller value. At certain angle of incidence, the reflected light will get completely polarized. And as I said, the surface is transparent. Some part of the light will get refracted and some part of the light will get reflected. And remember, the angle between the reflected light and refracted light will be 90 degree. When it became 90 degree, and the reflected light will become completely polarized. So AO is the incident ray, OB is the refracted ray, OC is the refracted ray, and OB is the reflected ray here. The reflected light is completely polarized. All right. So which can be proved mathematically here. Okay. So from the figure, we understood that S is the source of light. AO is the incident ray. OB is the reflected ray. OC is the refracted ray. MON is the normal, a perpendicular line which is drawn on the surface, which will give the idea about the angle of incidence, angle of reflection, and the angle of refraction. And XY is the surface or the interface between the two medium here. Okay. So now what I can write here is, from Brewster's law, you can write it as N equals tan IB. N is the refractive index. IB is considered as a Brewster's angle. Okay. So here, tan IB can be written as sin IB divided by cos IB. And similarly, from Snell's law of refraction, I can write it as N equals sin IB divided by sin R. R is the angle of refraction. So we'll call it as the equation number 1 and we'll call it as the equation number 2. Now we can compare equation 1 and equation 2. And here we can write it as, so from the equation 1, cos IB equals, in the equation 2, where sin R is there, which can be taken as cos 90 minus R. That's 90 degree. So now IB equals (90 minus R). So I can rewrite it as IB plus R equals 90 degree. If this minus comes this side, it will become plus. Now again from the figure, MON is a straight line. Okay, so MON will give us 180 degree. So I can write it as angle MON equals 180 degree because it's a straight line. So angle MON can be considered as angle MOB plus angle BOC and angle NOC. Here we are trying to prove that the angle between the reflected ray and refracted ray is 90 degree. So now what I can write is angle MOB plus angle BOC plus angle NOC equals 180 degree. But from the figure, angle MOB is IB and angle NOC equals what? R. Angle MOB equals IB, the Brewster's incident angle. BOC is unknown for us. Okay, now NOC is taken as R, which is equal to 180 degree. But here we have proved that IB plus R equals 90. So now what I can write is angle BOC plus IB plus R can be written as 90 degree, which is equal to 180 degree. So then angle BOC equals 180 minus 90, which will give us 90 degree. And remember, the angle between the reflected ray and refracted ray is 90 degree. Okay, that I can write it here as the angle between reflected refracted ray is equal to 90 degree here. So I can say that the reflected ray and refracted ray are perpendicular to each other. Then the angle of incidence is considered as Brewster's angle. All right. Hope it is clear now. Okay, from this derivation. So if you like this, kindly post your comment. Okay, the definition and the explanation I'll be posting in the description part. Okay, hope it is clear. Thank you very much. Okay, all right. We'll see you in the next video. Until then, take care. Have a good day.